Aspirators. In this chapter, you will learn about aspirators, what they do, how they work, different types and how they are adjusted, and how they are maintained. Aspirators are designed to remove lightweight impurities from the wheat. Lightweight impurities may include dust, gloom, and small or broken kernels. Aspirators can be situated at several points in the system. At intake, aspirators are used to reduce the amount of dust released into the air. Aspirators are located directly following milling separators. They remove particles that are lighter than wheat, but similar enough in size to have avoided removal by the screens. Aspirators are also located directly following scourers, where they remove any dust, chaff, or kernel pieces generated by the abrasive processes. The wheat stream enters the aspirator and is spread out into a thin, wide stream, usually by a vibrating tray. The stream falls through a current of air that is travelling vertically upwards. The current is adjusted so that it is strong enough to lift anything lighter than the wheat out of the wheat stream, but not so strong as to lift whole intact kernels. In some types of aspirator, the feeder tray is held up by a spring or counterweighted gate. The force of the wheat against the feeder tray should push down against the spring or weight. Spring or weight tension should be set to ensure that wheat enters the air channel across its full width. Aspirators can be categorized according to how the air current is generated. Some types are centrally exhausted using ducting connecting the aspirator to a fan and dust collector. Others are closed systems and are exhausted by built-in radial fans, though they may also use some external exhausting. In centrally exhausted aspirators, the volume of air used is controlled by a valve at the top of the channel. The speed of the airflow is also controlled by this valve, and by the position of an adjustable panel which acts as one of the four walls of the channel. The width of the channel is narrow at the bottom and wider at the top, causing the airflow to slow down slightly as it rises. The width of the channel at the bottom and top can be adjusted by hand wheels at these locations. Lightweight particles travel up and out of the channel and are separated out by intermediate separators, after which the air continues to a dust collector. Very heavy particles fall straight through the airstream. Most kernels should rise slightly at the base of the channel, but as the channel widens and the airspeed slows, these kernels should drop back down and out of the machine. This bubbling or cycling effect increases the efficiency of the aspiration. The airspeed and channel width should be checked for each new grist, as changes in kernel sizes and densities may require different settings in order to maintain optimal cleaning efficiency. Closed system aspirators with built-in fans may also have adjustable walls, but the light particles travel to an internal expansion chamber instead of an external dust collector. In the expansion chamber, the light solids are separated from the clean air. The clean air is fed back down to the base of the air channel to restart the cycle. The light solids are conveyed out of the expansion chamber by a screw feeder and an airlock. The speed of the air current can sometimes be adjusted via a valve or by changing the speed of the fan, or by changing the width of the top and bottom parts of the air channel. The sound wheat falls through the air current and then out of the aspirator by pushing through a weighted outlet gate. Regardless of aspirator type, the condition of the feeder should be monitored to ensure that the vibratory motor is functioning properly and the springs have not lost their tension. Expansion chambers should be monitored to ensure chaff has not built up or blocked the outlets, as this could represent a fire hazard. The efficiency of centrally exhausted aspirators is dependent on dust collector efficiency. Therefore, dust collectors need to be well maintained.